And welcome Wayne Roseberry. He's been working at Microsoft since 1990 as part of the engineering team. He's been involved in testing there since 1994. So he brings with him a great wealth of knowledge and experience. And again, reminder, please review in the app these wonderful presentations. And again, Wayne Roseberry.
All right, thank you. Thank you. So before I begin talking, this topic is largely process and analytics, sort of look at the problem. The problem goes very much hand in hand with code-wise design pattern stuff. And Matt Glasscombe over here has a talk tomorrow that's more design pattern coding. So if you're into this topic, I think the two go well together. It's because you really can't solve the problem without taking both approaches. So before I dig into the slides, I'm just going to ask everybody here, when you have chest pains, what are you supposed to do? Call 911, right? Why?
Because there may be something.
Yeah, you may be having a heart attack, right? Okay. So I did that once. And some guys came to my workplace and hooked me up to an EKG and said, oh, crap, we got to take you in. So they take me in and they put a stent in because I was having 100% blockage of the left anterior descending artery and almost died. But if you've ever had that happen, you suddenly realize you feel chest pains every day. Every single little thing that goes on right here. I mean, it drives my wife nuts. I'm always doing this, you know, and trying to figure out where it's coming from. And it's usually muscular. It's not like that. But it's not an exact signal, okay? But they tell you all knew. Every single one of you knew because it's on radio, it's on TV, it's on the web, everywhere. Everyone knows you feel chest pains, call 911 because the clock's ticking, maybe, okay? There's a lot of other things that cause chest pains, and there's other symptoms, pain down the arm, nausea, all which have other reasons. But they tell everybody this because of how critical it is, but it's not a very precise test, right? It's in the search world and other kinds of world, they call this a recall kind of thing. You want to get as many of them as possible, so you tell everybody this really simple thing that tends to catch them all pretty well. Okay? It's a recall optimized test is the way I like to put it. Now, anybody know what this is? Is this familiar to anybody? You can't really see it too well from here. What? Glucose test, and then just a stick pen, right? So this is for measuring blood sugar, which has a lot to do with the heart attack. It's very precise. Every morning I take this, and it tells me, with about a 10% accuracy, my blood glucose that morning. Now, I actually have to be careful the way I do it. I have to fast for 10 hours to get a fasting blood sugar. Otherwise, if I've eaten recently, it throws the measurement off. Also, if I want to know what effect food has on me, I eat and wait about an hour and a half to 2 hours, and it gives me a precise reading, and I can use that to kind of see how am I doing, you know, what's my exercise like, what's my diet like, and things like that. That is a precise measurement. It tells me one exact thing very, very well, okay? I like to say it's precision optimized, okay? This all matters later, okay? But I wanted to just kind of talk about tests in general and how they have these different optimizations. And so now let's go into flaky test automation, okay? I don't like the word flake, but it shows up a lot in books that talk about automation, and it's compelling, and it gets people to give you spots in conferences. So I chose it. And going from this morning, why is it important? This is why I think it's important. Oops, wrong one. This one. This is why it's important. This is a scientific description of a developer dealing with flaky automation, okay? You run the test, it tells you something, and you try to go figure it out, you run the test again, it doesn't tell you the same thing. Or the build goes out and they run a bunch of verification tests and someone says to the developer, you've got a bug! And they go and they run the test to see if they can make it, it doesn't happen, okay? Right? This is what it does. There's the frustration, the pain, and things like that, and that's what this is about, but there's also huge costs on the engineering team. And that's why it's important. Now, the topic is a bit wonky. I'm trying to keep it from being a big wonk number session. So a lot of this stuff is illustrative. There's going to be charts and things. Don't worry too much about memorizing numbers. I just want you to come away with these things. There's a lot to say about this topic, but I'm going to focus on these as an end goal. And it's really just 3 steps to deal with it and how we're dealing with it. You measure the flake, fix it as much as you can, okay? And then do a separation based on flake. And that's the end thing that it finally came up with, was the way we're dealing with it. And so now let's talk about those steps, okay? And there we are. So measuring flake. Okay, so I have a definition of flake. Flake is an inconsistent signal, okay? If something always passes, it's consistent. If something always fails, it's consistent. If sometimes it passes, sometimes it fails, it's inconsistent, okay? I like this definition a lot because it doesn't say the test is bad, okay? It just says the signal you're getting is not always giving you the same thing, okay? The other thing I like about it is that's measurable. We can quantify it. It's not that hard, right? You just take a set of tests or a test, run it many times over and over and over under the same conditions, and then measure how often you get the same thing, right? If you get the same thing every time, it's consistent. If you get a failure every time, that's consistent. But if sometimes passes, sometimes fails, inconsistent to a percentage, right? Fails every time, but with different symptoms, also inconsistent. This isn't really that hard a thing to wrap your head around, okay? And once you know that, you actually have a number that you can deal with. You can start talking about. Instead of someone saying the suite sucks, you can say, no, no, no. It's 99% consistent except for 1% of it, which has inconsistency rate of X%. Okay? So this is what we started doing because we were experiencing a lot of pain with tests that were flaking out. And this is one of these cases of these slides where I don't want you to focus too much on the numbers. It's just illustrative. So what we did, we take the suite and we run it multiple times. In this example, we're like 63 times, which is really quite a lot because it's a suite of like 20,000 tests that do all sorts of things to Office. It requires a lot of machines, many hours. And in this case, what I'm doing is mapping the slope of new failures. A failure we had not seen prior to when we saw it, okay? So the very first iteration through the suite, you get this huge pile of failures up in the hundreds. Okay, and then the next time down, it comes down to like less than half of that and on out with this asymptotic slope. Okay, cool, great. Now you've got this kind of curve of how much does this thing make new failures. And the fact that it even does this at all is an indication that there's intermittency in the suite, right? If this was a 100% reliable suite, we'd be done right there. There'd be nothing new after it. But it's got a long tail. Okay. What can you do with this long tail? Well, it's just a math formula that you can project the best fit slope to it. In this case, it's a power curve, maps really well. Power curve, logarithmic curve works really well on this one. Once you know the slope of this curve, you can do some pretty interesting things with it. Like you can ask the question, when's it going to be done? Okay, right? Now, if you look at that, you kind of go, well, maybe never. Okay, so you have to pick threshold. And actually, the truth is we've got some issues where the thing is identifying new issues that aren't really new, which does make it go forever. But you can pick a threshold and you can say, when it stops finding 1 per iteration, let's do that. Well, that's relatively simple. You just take and solve, instead of for y, you can flip it the other way around. If y is 1, and in this particular case, the slope we've got there came out at 921 iterations, you can ask another question. How many bugs will we find doing this by the time it stops? Well, okay, I was a speech major, but I did take business calculus, okay? That's the integral, which you can look up online and run on online calculators if you don't do that kind of math. But, and that will tell you how many bugs fit under that curve, okay? Now, there's several things that this shape suggests to us. First off, it explains why our engineers were so angry, okay? Because any given engineer, you'd get a bug coming back from like the build validation, and they say, you've got this bug, you've got to deal with it. And so what does the engineer do? They try to repro. It won't repro. They say, I'll run it 50 times because that's all the budget we gave them because there's only so much time we can do in the lab. It doesn't repro. Why not? It doesn't repro because over half of the bugs live all the way out here and go all the way up to in the neighborhood of 1,000. Okay? So to realistically try to reproduce these failures, someone has to be running the test that many times. And in fact, to some degree, the suite is exacerbating itself. So an engineer has to expend an enormous amount of energy to reproduce a test. Of course they're frustrated. And of course they ignore the results. It takes too much work. Okay? So that's one thing. You can kind of see, oh man, math kind of vindicates the engineer. There's some other things that you can do with this. If you think about this, it'll be done at approximately 1,000 iterations. Well, anything that's quantifiable is goalable. You can say, that's not good enough. What can we do? Can we set targets and say, how much do we need to fix this? What can we afford to run? Right? If it takes that long to run it, can we make it so it occupies half the amount of time? Or things like that. And you can start working on goals and things. Something else you can look at is, well, if the total number of bugs that we project would be 2002, how much effort does it take to get halfway there? We're not going to do 1,000 iterations every build, but if we only did 50, what is that? And you can just project using the math to find out and say, you know what, we only need to be 30% of the way there to get 50% or whatever it works out to. It gives you some interesting numbers to work with to get a sense of answering questions like, if I iterated only once on this entire suite, what's my confidence, right? Has this suite told me everything it can tell me? Well, and the answer is like, well, no, this guy was coming in up around the upper 100s or so, but it's going to go all the way out to 2002 before it's done, right? So now you know, oh, wow, this suite isn't good enough to really tell you what you need to know in this many iterations. And once you've got numbers on something, you can start getting kind of a command over it. It's no longer a mystery in your head, right? You get a sense of it. You get a sense of the shape of the intermittency. OK, this is about as wonky as I want to get, all right? So let's go back to my precision and recall thing. So the ever critical pain in the chest story versus the really precise blood glucose thing. I mentioned this, precision versus recall, right? And I got this. I had a way of talking about it, and some friend of mine from the Bing team said, "Oh, you mean precision and recall?" Okay, yeah, okay, fine, I'll take that. And I think about it this way: a precision test is one that will test exactly one thing. Do it exactly the same way every single time and tell you the same thing every single time. It's highly reliable. It tests exactly what it's supposed to. Okay? It's fast, right? And it's a Boy Scout. Okay. Recall tests. These guys tend not to do the same thing every time. They shake, they wobble, they do strange things, they go down odd alleys. They're not very reliable. They may tell you 100 things are wrong when really only 10 mattered, okay? They're less efficient, and they find a lot of bugs. But they also find your really, really scary bugs. They're the ones you never thought you had. These guys, they're kind of bugs you knew could have been there because you wrote something to look for them, right? And it's like, I know exactly what I want this to check, and we might get it wrong, okay? This guy, I don't know, make it do a bunch of stuff and see what comes out, okay? And it's the same thing with the heart attack versus blood glucose thing from earlier. Both are critical, both are important. But if you want to save the world on heart attacks, you just can't give out EKG machines and angiograms to everybody. It's not going to work. You have to give them something that is more recall optimized, okay? And you need both. And sometimes I think about test teams this way, right? I'm thinking that in this room, some of you think, I'm this guy, right? I'm the one who sees every single little thing wrong. If there's a pixel off on the page, I know it. I'm the one who goes nuts over the spelling errors, the exact behaviors. I know all the rules and things like that. And there's those people, right? And they're the ones that are like, just give me the app. Don't make me tell you what I'm going to do. I'm just going to do something to it, okay? And some of you relate to this guy, okay? You can't have a team of all of this. You have to have a team of both, right? And there's certain meetings where you better bring this guy. And there's certain events where you better bring this guy, okay? And in a lot of ways, the automation suite is like that. At least that's my feeling about it. I'm going to skip this except to say this is a unit test. It's very precise. It's precision-oriented. Test is just one thing. And it's atomic, because that's a word that Matt uses. So this is a recall-optimized test. It's a scenario test. It goes through and does a bunch of stuff in the app just to get down to the point of, this is what it took for me to insert a picture, resize it, and then, gee, what could have gone wrong on the way there. And the deal is that variance is built in. We're using a bunch of different files to change the inputs. We touch a lot of surface area getting there, and then God knows what went wrong. Okay? Now, both of these are going to do critical things, right? That first one is going to keep you from checking in, because it's very easy to blow. That was a URL parsing example, easy for someone to break that at a dev level. This kind of thing is like, I'm not sure what's going to go wrong, but all sorts of crazy stuff come up. Let's see. Yeah. OK, so this one, this one's funny. I did this analysis about 2 years ago, and we applied a lot of thinking about shoring up the reliability. So some of these numbers almost flipped, but the bottom line point is still true. And the question is like, what about the unreliable bugs? There's a knee-jerk reaction to most teams, engineers, engineering managers, and stuff, to take any test that doesn't give you reliable results and just boot it out of the suite. Part of that is the frustration. It's clear. They're hard to deal with. The other thing is that as we're pushing towards higher and higher velocity and releasing more frequently, you have less time to deal with it. Right? You start going from human-curated, big, long milestones to triage-driven, do we release today, do we release today, to like what a friend of mine at Amazon said, they release every 7 minutes. Something goes every 7 minutes, right? There's no human saying, does this code go? If this code is there, it goes. Right? So all of the validation processes, once that code's in, need to be automatic. Say it doesn't get in the pipe. Okay? You can't do this when the test is like, maybe. Okay. What's that?
I'm going to work today, but I'm not going to work tomorrow.
Yeah, exactly. You can't do that. So there's this knee-jerk reaction to kind of yank all those tests. But now let's look at the value. Okay? And so my proxy for value is, did you fix the bugs? Okay? And at the point I looked at this, the tests that were always consistent, means they always failed or always passed, were only contributing to about 4% of the fix pile. Everything else was spread across, but really jammed into the 70 to 90% of the time pile. Now, the numbers are, this is much larger right now. We put some effort and culled the suite and things like that. But it's still left with a very non-trivial fix pile coming from tests that are flaky. Okay? So this vindicates all the testers that I've worked with say, no, don't get rid of the tests. We need them. You do. You need them. There's an important other part of this picture. Is what percent of the bugs were filed, and what's the likelihood the bug will get fixed based on reliability or not. And at the time I looked at it, the reliable tests were just dumping them in, okay, burying the team, to be honest. Some teams had written robots that would go through and resolve all the bugs coming from our automatic system as won't fix. Just won't fix. And I'll talk about that later. But I'm not going to tell you which team, because you'll feel bad about them. But if you look at the fix rate, the reliable tests more than double the fix rate. Okay, it makes sense. They're easier to reproduce. Okay, people trust them more. People like them more. 33%, which actually is quite high. There's a lot of noise in this pile coming from the unreliable tests. So they find gold. They find things you want, but they're noisy. They're Calvin, okay? This is the Boy Scout, right? Okay, I'm going to talk just a slide here a little bit about fixing the flake. And this is one of these, there's a whole topic on this, and Matt's design patterns talk some of this. There is, when a team starts measuring their flake and they say, we got to make the suite more reliable, we can't give up on all the tests and things like that, you find a lot of engineering effort going into fixing up unreliability. Now, honest to God, most teams come in and say, it's the test. They suck. They're doing stupid things. They're sleeping when they should be checking more closely, who knows what. And a lot of them come out saying, whoa, God, it was the product. Okay, this happens a lot. Now, there's a lot of ground in tests doing dumb things. You see a lot of flying blind, just through a UI. I click, oh, wow, that didn't work. Well, I'll sleep for 20 seconds and see if the dialogue came back. You see that? But that stuff, honestly, once a team starts dealing with this stuff gets purged really fast. I was of the opinion that we'd find a lot of that, but when talking to engineering teams, they said, no, we got rid of that a long time ago. And I was looking at their models for dealing with, their patterns for dealing with this is actually quite sophisticated. So you get down into hard stuff, and you start talking more things like just reducing the amount the test is doing. Have it focus more and more and more atomically. A lot of places where teams would say they were end-to-end tests because we had two separate organizations. You had a dev team and a test team. The test team couldn't touch the product code, and the product code was untestable. You couldn't unit test it, right? So we had to test it top down. It's what the dev told me to do, that we get everything in one shot. So a lot of teams are like, let's move this into unit. And honest to God, moving the test into unit testing frequently is the refactoring of the code to make the testing possible that stabilizes the code. I'm not sure how many of you have gone through that process. If you ever read Feather's book, Working Effectively with Legacy Code, one of the most influential books I've read for me personally, this is probably one of the most important things you can do to stabilize code. But also just taking stuff at a UI level and web interface level, from user interface on the web level, and moving it to inproc, calling APIs loaded into the test code, gives you more control of it, things like that. So a lot of stabilization that comes from that. But in the end, you really can't shake it all out, okay? Because if you're not talking to a unit, and I'm of a very religious opinion that unit testing should never be unreliable. If it is unreliable, it's not a unit test, and the code's wrong. Okay, and we can argue about that at another venue. But as you go up and up and up and up the stack, the complexity in the code, runtime conditions, asynchronous behavior, systems you cannot control, okay, behaviors you cannot control. I was testing SharePoint for a while, and in lab, in the data centers, the servers sync to Active Directory for time, okay, which are synchronized with an atomic clock somewhere. Which means that as long as I'm in that environment, I can't test around time. I can't say what happens at exactly midnight, right? I can't do that test in that environment. It just can't be done. There's a variety of things that come up like this. The intermittency is intrinsic to the system in so many ways, and you just can't shake it all out. Okay, but there's a lot of ground there. It's huge. It's actually, you can stabilize a lot. And I always encourage teams to chase it as far as they can chase it until you can't afford to. And I've got some probably important things here. Mazzaro's with XUnit test patterns has some good things there. Matt's book and the Feather's book I strongly recommend. Okay, so once you fix this as much as you can, or while you're fixing as much as you can, this is what I like to do with it. I like to think now, especially as we go faster, when we were in long waterfall, it was like, write it, test it, ship it, okay? And we were conflating releasing software with looking for bugs, because it was all one giant thing. We could afford to do it. It didn't really matter. As it gets faster, you really can't afford that conflation anymore, right? 2-week test pass can't happen if you're trying to ship every day, right? And you just don't have that. You don't have the time for one-day test passes frequently, for a lot of things. Meanwhile, one of the key things about being lean, being agile, that feedback loop, that getting things quickly back at you, actually dominates the quality story a lot. Small batch sizes, little changes, get back your feedback from your earliest deployment as possible is a huge value in terms of assessing quality and getting things back in that are good, knowing how bad things are and stuff like that. And that starts to dominate really the quality story relative to other efforts. Because of this, gating starts to take priority. And gating cannot have an unreliable signal, okay? You really, as you go faster and faster and faster, you want the gating signal to be automatic, determinative. Just look at it, binary, yes or no. Did this pass or fail, okay? So I use this as a strategy for separating the test to two purposes. One is gating control. Do we go to the next step? Do you check in? Do you release the build to the engineering team? Do you send it to your internal dog food users? Do you move it along the pipe? Okay. And the other is bug discovery. You're just looking for things that are wrong. One is a process with high expense, high implications of failure, and very expensive because all your engineers on the team are going to be replicating this process to somewhat. So if there's anything in there, it blows back on everybody. Okay? And if it ever fails, it's a big expense. Versus, this finds me information. The information may or may not indicate a failure, but I need to look through and see what it is. I'm going to feed my backlog. And I'm going to reserve the right to pull the brake if I think I see something here that's going to screw the pipeline, but it's not primarily there to control the pipeline. And you separate in these. And the major separation here is, along with priority and severity and other things related to this, reliability of the test becomes a major criteria for these two things. Okay? You could pick only 100% reliable. You could pick 99% reliable. Whatever it is that is manageable for your effort. But this is the primary thing. So this guy is your Boy Scout. This guy's Calvin. Okay? As you get faster and faster, of course, and this is already happening, the bug discovery doesn't fit in the timeline for the pipeline. And it starts to go parallel to it, asynchronous to it. It's a signal that you use for information, but not really for gating control. Okay. Which I think is about where we're at now with the speed that a lot of teams and products are capable of deploying. I think there's another future point where this guy starts needing to get compressed into the pipeline as we start having influential escapes that change our mind about testing and production and quality. But the world is still trying to get the benefit out of fast deployment and feedback right now. So that's a future mountain, I think. This stuff isn't actually new. We've been doing this a long time. We've just been doing this in long waterfall models. But if you think about bug discovery tests, your first reaction is to say every new failure, feed it to the product team. If you're working with a large suite and you're automatically feeding that to the product team, you bury them. And this is where the robot came from in one of our teams. What the same team that wrote the robot did, though, is they used our repeated suite, the one with the big chart that I showed you from before, and started looking at the statistical behavior. That same robot looks at statistical behaviors on the tests and says, if your rate of failure has bumped up, so this failure used to occur like 1 out of 10 every 10,000 times, it goes to 1 out of 1,000, reactivate the bug, right? If it's above a certain threshold, reactivate the bug, and things like that. So good for them. They were deferring a work pile off of them, which makes them sound bad, but they were being very, very smart and saying, well, let's use data that we were giving them by running the suite for them over and over and over again. And I think that this becomes a necessity if you're going to say, yeah, I'm going to start using this kind of thing for bug discovery in a very fast-moving process. You have to use more analytical models. Another thing that you start finding yourself doing already, load tests are like this. One of the things that we would do with these end-to-end tests is we pretended we were precision tests. You would say assert fail if, which is a very precise way of declaring failure. But we're also trying to catch as many things as possible to say, and also if you ever see the word exception in the product logs, or the word error in the product log, or when we're running in debug, if you see an assert, or if there happens to be a process open that wasn't open when we started the test, things like that. And those were actually contributing a lot to the intermittency in the suite. That sort of broader definition of failure starts becoming more and more useful when you're saying, yeah, I'm using this to feed information but not gate processes. Whereas gating processes, it's a real impedance on the system. And then the thing about load tests, monkeys and load tests and things like that kind of drop, if you think about it, a lot of load tests drop that precise validation, right? Most of the time I've seen with perf and load tests is you don't check every single thing that's coming back. Like if you're load testing a web page, maybe you make sure you're getting something in the 200 range, okay? But otherwise, you don't really read the page in depth and make sure everything's on it. Instead, you load it for a while, bang, 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 maybe do some state transition, things like that. And then afterward, examine product logs, examine measurements on the system, things like that, and look for error, which works much, much better on bug discovery tests. Kind of turn back the precision attempt on the load and move to a much more analytical model. Let me see. Oh, questions. Okay. So.
We got about 10 minutes left.
Okay, great, good. I like to leave time for that. So please, hands up.
Well, first thing, what is Matt's deal for tomorrow? I'd like to make sure I get involved.
Plug. I don't.
No. I don't know.
Matt has a.
Just the name of the conference. Just the name of
Yeah,
the
Meta Automation.
Meta Automation. Okay,
Yeah,
thank you.
it's a design pattern talk. So other questions, observations?
Yeah.
What's
the typical pattern for if you have a flaky test decide, well, I think there's a bug here, and I'm going to make it actionable and set it over to a developer. So what information does the developer get, and how do they follow up?
Yeah. So in our system, so all of these are being done by an automated system that's kind of big and kind of huge and kind of been running for too long and needs to be changed. But it on failure, it of course collects the whatever the failure message was. It does a stack dump, so we get a stack trace of everything that was happening at a time. Collects system logs, like event logs, application logs, takes a screen snapshot, and puts that all off in a file share, and then that all gets sent to a developer that owns the component and says, take a look at this. So, yeah. Yes?
Do you use TFS and the test manager?
A question, if we use TFS, you mean Team Foundation Services?
Yeah, and also test manager, Microsoft test manager.
Yeah, so Office is in a transition to using Visual Studio Online. And so we really actually just in the last year switched over to using Visual Studio, which has TFS in it. The test manager, as a broad team, no. Individual teams here and there. So, yes?
So we have a set of flaky, 5% of our results are flaky, what you call flaky tests.
Yeah.
So it's been proposed to me that we introduce a concept of test case probation. So that concept is tests that are producing reliable results, those will give you your gating, quick feedback, bursts, that kind of stuff. And the probationary tests are the ones that require more energy.
Yeah.
Is that kind of equivalent to what you're talking about here, or is that something different?
No, I think that's the same thing. So he said that where they're at, they have about 5% of their tests are flaky, if we're going to use that word. Sorry, I apologize for that word. I got it from the Zaros on the X, but yeah. So, but and probation means it's not producing reliable results, so it's no longer a gating test, and that's a good way to talk about the metaphor here. My main thing is, I like to embrace the test because there's value in them. Okay, and I really went about this effort because I didn't want to see them thrown away, which was what the reaction was going to be if I didn't start looking and say what. So my recommendation is find something else to do them. Don't get rid of them, move them, and analyze them for value. Right? Figure out, are we fixing those? Are those uncovering things that we really want to know? I also think in the future, as we get better with telemetry, which is the thing I'm at work trying to wire up right now, is to correlate customer telemetry signal, customer problem, with what do we see in the automation, right? Can we say, oh, look, the customers covered these code paths, see these problems. How come the automation did not, right? Or maybe the automation did, and you didn't realize how important it was to the customer, right? Because, a bug is just a bug until it affects someone. And then it's a problem, which is kind of what the last presentation was about, right? And so I think that this is something that we should all be trying to figure out how to do, is to assign good value to those failures.
Right. So one of our test teams, what they do is they have probationary test runs. So they're run in a separate automation run path, so that they have their own life cycle. But I kind of like the concept of, so maybe you're running them over and over and over again to establish some kind of pattern or statistics or something. You're applying a different model.
Yeah.
To what that data means. Something earlier today, I can't remember the presentation, but I've gone from, you say flaky, but I like the term test reliability. We've used the term they're false negatives. But really it's, what's the difference between a false negative and an intermittent failure? So you really have to take a different approach to what's going on.
Okay, so I'm going to talk about the last thing that you brought up there, because I think it's an interesting question. So the question he asked is, what's the difference between a false negative, or false positive or negative, and an intermittent failure? And the key is this one, whether or not it's intermittent, with a false negative or positive, it's telling you something that is not true, right? Intermittent is, it's not doing it the same way every time, right? Under the same conditions as far as you can tell. And it could be telling you 100% truth every time it fails, right? Or it could be lying to you. But the key thing is that it's not doing it the same way every time. So, but actually, this is a good point. Some of these really high-valued failures are also given to you by tests that lie to you sometimes. And I think it goes back to, at some point, the flake and the shake is intrinsic to the complexity of the problem you're testing. Yes?
So with the test that you ran, so say you ran them 1,000 times, right?
Yeah.
Were you looking for any other metrics? For example, tests that took over 5 minutes were the ones that were flaky, or tests that had the maximum interaction with third-party services were the ones that were flaky. Any other metrics that you were looking at?
I like that question. So the question was, like, when I was doing the analysis, was I looking for other kinds of correlations? Slower tests that interacted with other systems and things like that. And the answer is not as much. In terms of slower, because of the way our system collects data dump when the failure happens, they're all slower if they failed, because we spent a long time doing the call stack dump and stuff like that. And the database level, we just know, the failure occurred at some point. You have to go into a per test reading of the logs to get the time difference, and that was just way too much to undertake without some better tool to do it. And then it's kind of the same on the interaction with other things and stuff like that. The very, very detailed level analysis, no. Mostly because this is the kind of stuff I could query out of the database, and the rest of it required a deeper analysis into logs. In tests I didn't own. That's the other thing. I don't own any of these tests. This is owned by thousands of people across the org. I would love to do that. It's actually a project I would get in more root cause analysis and categorize what drives failure. Because I think just as a general discipline, I think we would find a taxonomy of categories of what drives flake in a test that I think would be helpful just in general. Yes, Matt?
So for the failed test, and you're talking about you would love to find more information on root cause analysis. Did you ever find that some of the tests which were flaky were failing due to some race condition on either an external dependency or something over which you have no control, like a slow network, for example?
Yeah, I'll use, a question is were they failing over things that you had no control over? And answer is yes. So one of the teams that has, I'll out them, Outlook. I'm outing Outlook. One of the teams that has a lot of difficulty stabilizing their tests is Outlook. And the reason is because they are a mail client, right? Everything they do talks to a mail server, Exchange or an SMTP server or something. And they have to talk to an identity system, Active Directory or Live or something like that. So there's a huge dependency on race conditions against those servers just to do the simplest operation. And this means that they have to have a whole bunch of robustness built into the test just to say, look, I'm going to go in, take this user I've been randomly given by the system, send a mail to myself and see if it comes in, right? Which sounds like the dumbest little test, but the amount of moving parts that are there, and it's very, very difficult for them because of that. And if anybody's working on client components in a client server system, you probably have had very similar experiences between your ID system, between talking to third-party servers and things like that.
So how do you deal with those kind of failing tests? Because that's my life, pretty much.
Yeah.
My flaky tests are failing because of an external system. So how do I stabilize that? Or how do I deal with that?
Yeah, so the question was, I'm going to oversimplify, is like, well, how do you do it when it's really, really hard? How do you deal with the test when I don't actually have a good blanket answer on that one. I haven't done enough of that. A lot of people find that when it's that complex, they either just admit it's going to be flaky, and we're going to have to figure out how to deal with it in noise abatement, or they rely a lot on stubs. I find a lot of teams that are in positions like, look, we've just got an SMTP stub or an Exchange server stub, and we have to rely on that. And that means they miss things, right? They won't get to all of those failures, but at least they can move certain things closer to the gate, right? And it's just, this is one of the problems, is we are talking about a solution that is compromised, right? If you're going to release really fast, that you're going to go through the gate with bugs, right? And if you're doing staging control and release control and ability to update quickly and get the monitor and the telemetry, the reason you're doing that is because you know you're going out with the bugs because you did not leave the time for the full testing, right? And you make compromises like, we'll build the best stub we can that will cover the key issues, but if something terrible shows up in the signal, we know we can get it fast. And this is, Keith, you're back there. I got this from you several years ago, that sort of the components of testing and production and fast delivery. And there are these things where it's like, if you cannot get a good telemetry signal, isolate, control the release, and back out fast or update fast, don't play in the game. Okay? And this is also not throw over the wall. All of your testing and production is intentional. It's with a plan. You know exactly what you're looking for, exactly what would make you pull the brake. We act like testing and production is flippant, but it's not, okay? But it comes with this compromise. I know I can't do a full end-to-end test. That first roll into production with a bunch of synthetic users and monitors is the first end-to-end test in some cases, right? Which, it's kind of a scary world. I'm waiting for the big, I call it influential cataclysmic event that convinces us Agile is wrong. But it hasn't quite happened yet. Our Titanic may be coming someday. But so far, we have figured out, well, here's how not to do it, right? Which I've been using your stuff for a couple of years now, Keith. I liked it. Yes?
Actually, I
Oh.
have a question. Exactly. So I have multiple questions. So you said when the test phase, the results will be sent to the developer.
Mm-hmm.
So the QA doesn't look at them in the first hand.
Yeah. So the question is like when our test fails, it's given to the developer because QA doesn't look at it firsthand. Actually, I sort of lied about that. In fact, actually, at Microsoft, yes, that is true. We don't have testers anymore. So we're all developers now, or software engineers. But before that transition, the test system has an owner assigned to every single node, right? And so any given test in there, whoever the owner is, the failure would get assigned to them. Unless you're the one that launched the test. If you launch the test job, the failures get assigned to you. But if it's like one of the main build processes, then whoever is the owner of that, which tended to be the tester, but could likewise be the developer. And then if it was the tester, it depended on your culture. Because some test teams felt more under the boot of the developer, and they had to figure out every single failure before the developer would look at it. I knew one test team where the tester had to get the failure into the kernel debugger on the line of failure before they could bring a developer in to approve the bug being filed. And I told them what I thought of that. But and then there are other test teams, like the one I was on for a while. We were like, we've been looking at this, and 80% of the time it is your bug. And so we would just the moment it got filed to us, we would just, boom, over to the developer. It's like, prove us wrong. But it was, you had to have a dev manager that was cool with that. So it's all people, honestly. It's all people and how they get along with each other. We talk about official processes, but it's how you're getting along is the answers to those things, I think.
So you also mentioned that
Yeah.
now the QA is going to go away, especially in Microsoft.
A QA doesn't go away.
I mean,
Yeah.
everybody is a developer, engineer.
Yeah.
So that's the automation traditionally handled by QA. Will the engineers going to take over? How is it going to work out?
Oh, so we're going to talk about combined engineering now. I can do that. That's cool. It's a fun topic. So the question is when the QA was traditionally, the automation was typically owned by the test team, what happens when you combine? And the answer is well, it depends on who your engineering manager is. Some engineering managers say, we'll have a whole dedicated team to just the QA, and we'll take all of the people who were testers and they'll own it, right? And then others would say, nah, it's just everybody, if the test was for your feature, bam, it's your test now. If you get a failure, it goes to you. There's one team where the engineering manager, had a polite conversation with one of the test leads coming in saying, I know you've been working on this automation for years, but I've got this guy over here who's my top lead in my dev team, and he really needs to be in charge of this problem now. And it's not an insult to you, but it's because I've got to get this dev team used to it. And so he did. He put his top guy on the automation problem. So again, it's the same answer as my last one. This is a people problem. Exactly what you do is based on the mood of the team, who's in charge, and how they do. Personally, I kind of like the last story I gave you. I like that attitude. Saying the test team owns it on the way in, it kind of felt sort of cheap to me. I like to say, let's put top person in charge of it. But it's you got to adapt it to you. That's what really works best, I think. Anything else? Because it is late.
We're just about out of time anyway.
Okay, great. Thank you.